Myself Chisutar, a student of BTech in fourth year of electronic engineer. Today I am here to present a PPT and a project demo of my internship that is completed through Image Information Technology. The project was on IoT-based home automation system. The topics we learned during internships are C programming. In C programming, we have learned various things like keywords, basic data types like int, char, flow, double, void operations. Um, we also learned conditioning and looping concepts, arrays, pointer functions, the storage classification of preprocessing directories and header files. We also learned C++ programming, the concept of OOPs, introduction of IoT, its definition, its architecture, and also in introduction to embedded systems, in definition, types, and components of embedded system. During this project, we have used various peripherals that we have learned like LED, Arduino UNO, CLCD, and ADC controller. Peripheral requirements of these projects are LDR sensor. LDR sensor reads the light intensity and accordingly control the garden lights. Temperature system. In temperature system it include heater, cooler, and a LM35 temperature sensor that change during the surrounding temperature and accordingly control the heater cooler. A serial tank is used in our project as a virtual version of our original tank. Coming to the next slide, the slide says what is information of things, that is IoT. It defined as the IoT refers to the network of interconnection of physical device that can collect, share, or act on data through internet without requirement of direct human interaction. Imagine a smart home. You have a smart bulb that turn automatically when you enter to the room. Such things are called IoTs. Next slide is of what is embedded system. Embedded system is an combination of hardware and software designed to perform a specific task or a function. Okay, with the large system, it is called embedded because it is built inside the device to control and monitor its operation. Examples of embedded system are home appliances like washing machine, microwave, and refrigerator. It's also used in automobiles like airbag system, ABS braking controls, electronics like TV remotes, and digital cameras, calculators. In industrial, embedded systems are used widely in motor control unit, PLC systems, and IoT devices such as smart home control, ESP-based automation systems. Our project requirements are as follows. The first requirement is controlling garden lights on basis of sun intensity. Next is a temperature system control, switching heater and cooler on or off remotely using Blynk IoT. Switching heater off automatically if the temperature go beyond 35. Water tank control, switching inlet and outlet on or off remotely using Blynk app. Switching inlet valve off automatically if the tank is full. Switching inlet valve on automatically if the temperature drop below 2000 liters. Next requirements are hardware requirements. In hardware requirement we use Arduino UNO ETH-W5500 Ethernet shield to connect Arduino through internet. A temperature sensor to detect the temperature, LCD, LDR sensor, and LED. In software requirement, we have Arduino IDE to program our Arduino. PIC SimLab used to simulate our whole project. Virtual serial port drive is used to connect Arduino and a serial tank. through it, an IoT app to control our appliances remotely. First is Arduino UNO. Arduino UNO is based on a 80 mega 328p microcontroller. It's a basically microcontroller used in many projects. It's an easy to compare to other boards such as Arduino Mega boards, etc. It has six analog digital pin input pins and 14 digital pins, a USB connector, a power jack, and a ICS-SP header. That is nothing in circuit serial programming. This is a overall view of our Arduino. Um, this is a power USB connector. This is a 12 volt power supply connector to our Arduino. This is the main controller of our Arduino UNO. These are the analog pins and the power pins. These are our digital pins used to connect our Arduino to digital signals. This is our indicator that tells us that the Arduino is on, and this is our different LEDs. This is our reset button of our Arduino. Next is ETH-W5500 Ethernet Shield. It is a chip that hardware TCP/IP embedded Ethernet control that provide easy internet connection to our embedded system. It enable use to have an internet connection to the appliances just by using the single chip, in which TCP and IP stacks 10 by 100 Ethernet MAC and PHY embedded. It supports power down mode. It also supports wake on LAN or UDP. Support high speed serial peripheral interfacing with module mode of 0.3. Mm. These are two okay. These are two pictures that shows our Ethernet shield. The first one is a virtual Ethernet shield, and this is a shield that are available in market. Just look same. This is our Ethernet connector, same as both. This is a crystal of frequency. This is a controller. These are the pins that control virtually. These are the hardware pins. Next is temperature sensor. This is an LM35 temperature as shown in this schematic diagram. It is an electronic device that measures temperature of the environment and convert it into input data in an electrical data to record, monitor, or a signal change. Next is LCD HD 44780. It's an dot matrix liquid crystal display that is used in our project to display the notifications such as on, off, and etc. It can be configured to drive a dot matrix LCD under the control of 4 and 8-bit microprocessor. This is an schematic view of our LCD. These are two lines of our LCD. These are connectors. In this project, we are connecting it as virtual. Next is LDR sensor. It is a component that have an variable resistance that change when the light intensity falls on it. This allows them to be used in light sensing circuits. The resistance of a photoresistor decrease with increase in light intensity. In other words, it is exhibited photoconducting. Uh, Extract of our project is as follow. First is home automation using Arduino and Blynk IoT app. In this, we have using Arduino in PicSim simulating app. Next is controlling garden light based on weather, that is day or night. When come to night, the light should automatically turn off, and in the daytime, it should be off completely. Controlling fan means cooler and heater based on weather, such as hot or cold. If it is hot, the cooler should on, and if it is cold, the heater should automatically turn off. Okay, in this we are using heater in 35 temperature. If the temperature go beyond 35, it should automatically turn off. Next is controlling water level of tank based on its capacity and sending the notification to CLCD and the Blynk IoT application. Uh, the functional requirement is as follow. Okay, whenever we need to control heater, cooler, or tank inlet and outlet valve, first of all we use an Blynk IoT app here. Whenever we turn on or off, it go to the Blynk servers or a cloud. Then it return to the our simulating application through this Ethernet shield, and it is processed by Arduino and accordingly change temperature on, temperature off, or inlet and outlet off and off in our home. In the next slide, we have garden light controls. Reading the LDR sensor values based on reading of LDR varying the brightness of lights. Okay. Here the when the light falls on LDR sensor, it detects the intensity of light and accordingly a pulse is generated to the Arduino to control the lights. Next is temperature system control. The temperature system control consists of heater register, an LM35 temperature sensor, and a cooler, which resemble the temperature system at our home. Reading the temperature from temperature LM35 sensor and display it on CLCD. Controlling the temperature of our system by turning on or off of heater and cooler through Blynk IoT app, as we have buttons on our Blynk IoT app. Now here we have our Blynk IoT app, which include widgets and grooves. In widgets we have buttons that control temperature, heater control, cooler control, and a notification. Arduino is used to control all these peripherals. CLCD is used for notification and temperature control. Next we have water tank inlet and outlet valve control. By reading the volume of tank through serial communication, it display on our CLCD display. Control the volume of water in the tank by controlling the inlet and outlet valve. By sending a command through our Blynk IoT app or automatic code we have written in Arduino. It also display the temperature in our Blynk temperature and volume of the tank in CLCD, as well as our grooves on our Blynk IoT app. We have next slide, the user interface. In this project, as we know, we are using Blynk IoT app that is designed for IoT projects to control equipments remotely. It control hardware remotely and it displays sensor data in real time, like what is the temperature and what is the volume. We have some buttons to control it. In the mobile Blynk application, we have button visits and groove visits. Button visits are used to control heater, cooler, inlet valve, and outlet valve of serial time. Groove visits are used to display temperature dropping or increasing, or a volume currently what we have in our serial time. This is an overview project view we have to see in the demo part. This is an CLCD display. This is an Ethernet shield W5500 used to connect Arduino to internet through LAN cable. This is our temperature sensor. This is an heating temperature register that increase temperature. This is a cooler fan which decrease temperature when we turn the cooler button on or off. This is our um, serial tank connected to COM4 with Arduino virtually using uh, port serial driver. This is our garden lights such as LDR, and this is our light. When we vary this slider, it acts as a light intensity decreasing or increasing, and accordingly change the garden light uh, more or less. Coming to the next slide, we have conclusion here. Um, First conclusions say that using Blynk IoT application and Pixim simulation lab, we can simulate our home automation project where LEDs, temperature system, serial time, heaters, coolers, and the water tank in real time with application and a virtual project. CLCD act as a dashboard that tells the events, means when we turn on the heater it shows heater on, cooler on, and etc. Groove widgets in the are used to display the temperature on our Blynk IoT app. Now, thank you for the presentation. Now coming on the project demonstration. Here we have our project, virtual project in Pixim Lab. Here you can see this is an virtual Arduino UNO. This is our all peripherals such as a CLCD, Ethernet shield, temperature system, LDR, and a light. This LDR and light act as a garden light. This is our heater and cooler system. Here we will get our all the notification in CLCD. This is my mobile mirror to the website, so I can show you how the Blynk app works. This is our cereal tank. Mm, Now, starting with the project, our first requirement of the project was garden light control. Here, now the light is off, means it's in daytime, no high light intensity. N- Now, when I use this slider to decrease the resistance, the light will glow up, acting as a nighttime. Now, as you can see, I have increased little bit. The light has dimly grown up. Now, when I increase it more, the light is completely turned off. That shows it's a night time. Now, now in the display you can see that she's showing a temperature and 3000 as a volume of our cereal tank. Now, whenever I will turn my peripherals on or off with this Blynk app, the notification will be appearing at the right side of our CLCD. Such as see, in our Blynk app, there is an temperature showing group that shows the temperature, and same as volume that shows 3000 as our CLCD. Now, as same the temperature also same. Now here we have four buttons that named as heater, cooler, inlet on, and outlet off. Now as our tank is full, when I turn on the outlet on button, the tank will turn, emptying the water from the tank, as we can see. Now, as I have turned the outlet flow off, you can see the water is coming out and the notification is appear here. The outflow is on. When I will be turning it off, you can see that Blynk app has been turned off. The water is stopped, and a message is appearing here that says outflow is off. Now, whenever the water flow go below 2000, the inlet valve will be turned on automatically and replicated in the CLCD that says inlet valve is on. First, I will turn on the outlet valve that should water should go below 2000. See here, outflow is off, water is turning off, and same time outflow is off, and inlet is on when when the volume of water go below 2000. Now you can see inlet valve is off. Now when I turn outflow off, and you can see here message appears, the water is emptying, and when it go below 2000, the it will turn off. Now, as you can see, it turned off and inlet valve is on. And the same message is appearing here, inflow is off. When it will get full, means 3000, it will turn off automatically. See, inlet flow is off. That's our serial tank peripheral connections. Now, coming next to the heater and the cooler buttons. Now, when I will turn on the heater button, the temperature will grow, rise, and when the temperature go beyond 35, it will be cut off automatically, and the message will be appearing beside it. And when we turn on the cooler button, the fan will be rotating, and the temperature will be decreasing. Now, as I on the heater button, you can see heater is on, message is appearing, a temperature is rising, and when the temperature is rising, when it go beyond 35, as you can see here 35, it will turn off and a message will appear, heater is off, and temperature and the button on the blink app will also be turned off. When I will trigger the cooler button, see here cooler button, the fan is rotating and the message appear, cooler is on and temperature is decreasing. Now, when I also turn off the cooler, the message appears, cooler is off and temperature is below 35. Again, I will turn on the heater button. You can see heater is on, temperature is rising, and when it goes beyond 35, turn off. As you can see, it go beyond 35 and the message appears, heater is off. And you can see the same replica here that heater is off now, and the same temperature and volume is here. I will turn off the outflow once again, and outflow is on, water is coming out, and again I will stop here only. That shows outflow is off, water is stopped here, and the same amount of water value is here, and same here on the CLCD. This is our interconnection of our project, which demonstrate our whole project with the uh, Pixing Lab and the Blynk IoT app with the serial remote tank that shows our whole project is working fine, and the project is completed finally. Now, when we connect this serial port, now how we connected this serial port to the Arduino is using this virtual serial port driver. Here we created two ports, COM1 and COM4. COM1 is for our Arduino, as you can see configuration. COM1 is connected to the Arduino, and you can see here COM4 is connected to our serial port that enables internet connection with both using our Ethernet shield. This was all of our project. Thank you.